Okay, so okay, okay. So in today's class, we are going to discuss first a simple thing called streaming job, and then we are going to do the discussions on the problems we l- discussed yesterday, and then we'll move on. All right. So here we go. So for all of the people who actually wonder that can they write MapReduce without using Java, streaming job has been like wonders, has been really, really useful. Okay. So basically, some people who are from Python background or Unix background, they made it possible to use MapReduce, Hadoop MapReduce using any programming language. Okay. So the syntax is you start with a command like Hadoop, and then you first parameter is jar, and then the library of Hadoop streaming. Okay, so you remember yesterday we were talking about. Okay, let me just send it as an email to myself, right? So okay, so where I will be writing, I'll just write down the note, okay, to myself. So Aklesh's question, I'm making a note. I'm basically making a note so that I do not forget it, because this is the only one question I have forgotten. And it, okay. So generally I make the note by sending emails to myself, and yeah, that is why I hid my screen. All right. So okay. So we'll cover it in the next session, and we'll see if I can explain to you. Okay. So if you have a actual question, can you just send an email to me, or did you send an email already? Otherwise, I'll have to dig a bit to find out what was the question. So basically, in very brief, Apache HD Insight is basically pure 100% Apache Hadoop ported onto Windows platform. All right, it's as simple as that. Hortonworks guy did a lot of things. So HD Insight is basically Apache Hadoop ported onto the Windows platform. Okay. So we'll see if we can, keep a brief introduction about HD Insights also, right? Okay, great. So let me continue the discussion right now, and we'll keep that in mind. So maybe we can include a few slides with respect to HD Insight and prepare a demo. Let me just see that. All right. Now, So for basically this Hadoop jar is Hadoop streaming jar is the one which makes it possible to use standard uh, to use any programming language on any programming language or any binary. All right. So the way you define is Hadoop jar, and this is like fixed for all. And then input file, where what will be the input files, that folder you can provide here. Okay. If you have a single file, you can just say a single file, or you can provide the folder also, and the output folder. And then you can provide any command as mapper or any command as reducer. All right. You can provide that. Okay, so this is if you remember yesterday we talked about you know, we talked about SED command, and we talked about unique command. So basically you are using these Unix command as mapper and reducer. Okay, here the mapper is nothing but something who has converted the lines in who has converted input text such that the each line is containing single word. All it did was replaced space with a new line. That's all. Okay. Replaced space with a new line. So this is a command, Unix command, which can be executed uh, on the terminal as well. And similarly, whatever result came out of the the Hadoop was passed through a reducer, and all reducer did was a unique minus C. All right. So this is Hadoop streaming. Okay. Now let's talk about what happens actually. Okay. So again with the same kind of input, say this is your file. These are basically billions. Here this is a single line for demonstration purposes. In reality, there will be billions of lines. Okay, and you replace space with new line, and then in each line you got word. Okay, you got a single word in each line, and after that, after that. Uh, After that, if there is a single reducer, generally you can, for time being, you can think of it as that all of this single is passed through unique minus C, or even here you can think of the reshuffling. During reshuffling phase, the same keys are sent to the same machine. Okay, and this is wrong, this is wrong. Okay, here it has to be sha sa. Okay, okay. So basically, in the reshuffling mode, after it got sorted, here your map program, which is basically replacing space with the new line, converted into a file or input, which is having one word per line, is sorted and reshuffled such that same keys are going to the same node, and same keys are being passed to the same reducer. Unique minus C, all it does is it prints the frequencies of the word in the input if it is sorted. Okay, so here the frequency of SA is 2, here frequency of RA is 1, frequency of GA is 1, and then it gets merged, and this is your output. All right, so this is a streaming job. So the way I have used here my SED command, similarly you shall be using your own Python commands, whatever Python commands you have. But the only downside of this is that you will have to copy the command across to the whole cluster, and that will cause a bit of a problem, right? So in reality, you basically copy the command onto the cluster. Okay, because this command has to be there on all the nodes where because say unique is happening on all machines. Similarly, mappers will be running on at least whatever machines are there, wherever your file is located. Say if this file here, we are showing it that there is only one mapper being run, but there could be like hundreds of mappers if this file exists on hundreds of nodes. Okay, so all the data will get merged, sorted, and then passed to your reducer command. These ones in the frame, the white frame, are basically your code which you have written or your command which you have passed. So let me give a demonstration to you. Okay, so let me just take this one, okay, and then try to see if I can run this. All right, so I'm going to the Hadoop cluster. Is font visible to you? Now can you see? Or should I increase the font? Okay, okay, okay. Right. So here you can see that Hadoop fs minus ls, and I go into asgiri and word count. Okay, so word count has got input. So Hadoop fs is the general way, and this is my file. All right, and this file is what we are going to churn the data on, which is in the asgiri word count input folder. And all right, now let's just do this. So okay, let me just say, so do we have, okay, I'll have to basically locate where my, let me just see if I can, not a valid jar, find name Hadoop streaming, because on every machine, on each kind of installation, it will be at a different location. Okay. Huh. So we have got Hadoop MapReduce streaming over here, and we can say now Hadoop jar and then my jar file. Let's see what happens. It says that it says that you have to basically, these are the various options. Okay, these are the various options, and we can say in my input is what was my input? This is not this one. This one, yeah. Okay, this is my input directory, asgiri slash word count. That's where I have kept my file. All right. Now let's go on and right, input here, and my output will be in the same folder, just with the output. Okay. Let me just call it X, and then now I have to define my mapper. For time being, I'm just assuming this, and this one. Now let's see if it produce any output. So it's saying it is doing something. Total input paths to process is 1, number of splits is 2, submitting tokens for the job, submitting application, The URL to track is this, and now it's running the job. To track for every job, whenever a job is executed, the job tracker gives you a special ID with which you can track. Okay, so job tracker is generally available at 8080, and this is the status you can see on the web. All right, and if it fails, then it gives you an error. And so what exactly the error I'm facing here? Okay, okay. So it says that it has failed. Okay. So one of the node did fail, so it quickly recovered from that one and executed the code on other node. All right. So that was the first attempt, and that failed. Okay. And so it quickly recovered and did the use the another node. Okay. Now here it says that one of the maps failed, and then later on it was successful. Okay. So okay. So both of them are now successful. Two failed, zero killed, two successful. There were total maps. So basically, it was reattempted, and in the second attempt, it was successful. Okay. Now it says that at the end of it, the output directory is this. Okay. Now let's check if something has generated over there. Hadoop. And in parallel also, if you have a browser, you can go to my directory as Giri word count using Hadoop 1.nobigdata.com colon 8 triple triple 4 times 8. All right. Hadoop fs minus ls. So it says that there is one part here. So it shows you that there is only a single reducer. Had there been multiple reducer, there could have been multiple parts. All right. So by default, uh, I mean, here you see part dash 000. In this output X folder, if you have multiple reducers, then it will create multiple files for you here. Right. So for most of the streaming jobs, by default there is only a single reducer. All right. But you can mark it, okay, using number of reducer on the command line over here. All right. So you should try that out. And yeah, let me just see. I say cat and output X part. Okay. So this command says that Hadoop. Okay, now can see that. So I'm trying to see what is the frequency. These are the frequency which is computed for each word. You can see that, right? Similarly, if you see the input directory. So input directory, how would you see? Here you will say input directory and say all the files inside it, and then cat. So this was our input file. All we did was first converted the space into new line, and then did a passed it through the mapper. The mapper converted this file, this big file with the lines, into one word per line, and then all it did was uh, gave it to the Hadoop, and Hadoop sorted those words, and after sorting the words, it gave it to the reducer job. All reducer did was reducer executed a Unix command called unique minus c, which basically the gave you the frequency because the words were by default sorted. So So this is the output. And note that these single quotes, since we have not taken any extra precautions, because we have just replaced space with a new line, therefore single quote, double quote, and everything is being counted as part of words. We can further cleanse this data using commands like breaking it, instead of using just this one, we can use you know anything which is not A to Z or capital A to Z. Okay, so this will basically break the break the lines by anything which is non-alphanumeric, or you can say like this. Okay, or you can say plus. So anything which is non-alphanumeric, it will break that one, and and then you will have a better input. So you can try that out when you are at your own time, all right, using various kinds of pattern. And this command you should definitely give it a shot. Let me update the presentation with the actual directory which I'm using so that you don't face any problem while trying to execute this one. Okay. So you can basically try it with different kind of patterns in your free time. Okay. And if in case you do not know about regular expression, make sure that you learn it. Make sure that you learn it because you will encounter regular expressions more number of times than you can expect. Okay. And when you're executing this command, this part, this part is something you should change because in case you try to execute the same command again, which I executed, you will get an error immediately the way I'll just get an error saying output directory exists already. All right. Also, instead of using my folder, you should create your own folder and put the output there. All right. So you should generally create something like your own folder, say my login, whatever your login is. Okay. So, and then you put it in the output folder. All right. So, and let me see if user lib Hadoop MapReduce and Hadoop streaming. Okay, so are you going to give it a shot after this session or parallelly whenever you get free time? Give me a yes. Oh, today Meenal hasn't been able to join, and there are two more persons. If data in different file other than text, how to read content? All right. So basically, in those cases, you will have to make arrangement to read the text from those data. Okay, or even the binary can be handled by MapReduce, but the key you have to give, you always spit out the key and the value. All right. So I mean your mapper code should understand the input format. Only then you will be able to give out the key and the value. Okay. Here here all it did was, here in this particular one, our sed command understands the input format. Okay, so all Hadoop did was took all this streaming job did was took all the files in this folder, and concatenated all the files in this folder and gave that input to sed. Okay, now if this content which is being given by um, streaming jobs, which is there in the input here, if it is binary, right, then your SED should be able to understand and deal with it, or your command here should be able to deal with it. Say you have got a binary file here. So, and you know how to deal with binary file, and all you did was used a command called strings. Okay, strings take out the strings from any binary file. Okay, now you can process it. You got my point, Akhilesh? So basically your mapper code will be able to understand that. So Karthik's question is, what is the difference between Java MapReduce API and streaming API? Basically, under the hood, streaming API is calling the Java MapReduce. Okay, it is basically the Java code which converts these commands into Java MapReduce and calls them. The biggest difference lies in the way streaming deals with the data. Streaming basically gives out instead of instead of grouping values together like a array. Instead of doing that, it just gives out the sorted data to the reducer. Okay. So instead of grouping it together, it will basically give out the sorted data. Unlike unlike here, making it sa 1 comma 1, he's just passing sa to unique. Okay. So streaming jobs doesn't group it. Okay. The way it calls MapReduce, it only basically gives out the sorted data to your reduce command. Okay. So that makes it quite useful. Karthik, was I able to explain you the difference between the two? Okay. All right. So that was you should give it a try. Make a note of this command, or you take a copy from the presentation, and make sure these quotes, right? These quotes automatically these you know are altered by the presentation and the PDF. So make sure you type these codes again in your command. Delete these codes and then type these codes again. Okay. Here outer one I have put single because that is interpreted by the shell, and inside one I have put double quotes. Okay. So outer single quote in case of a Unix, make sure that in inner one is not interfered. All right. So that this was the streaming job for the word count. How do you do the word count using the standard one? All right. Similar way, basically, in my experience, when I was doing Python, so I wrote my Python command over here, and at the top of say my command, my command, my file is xyz.python. So I make sure that the top of it I mention this user bin Python, and on the streaming side there is a Hadoop streaming. There is a variable. Okay, there is a variable which makes sure this is the streaming manual actually. Okay, it gives you a detailed version of detailed manual of streaming job. Okay, and here here there is a way to specify the number of reducers. Okay, you can specify number of reducers by yourself. Okay, and here it says map_red reduce task equals 2. Then output folder will contain two set of files. Okay, you should try that out. And okay, And most of the other dynamics we'll be discussing later on, such as partitioner, combiner, those those other detailed part of the MapReduce we'll be discussing in today's session or the next one. Okay, so this is pretty much about the Hadoop streaming. Okay, so how many of you tried this, or how many of you thought about this question? Frequencies of letter A to Z. Do you need to compute the frequencies of letter A to Z? Do you need map/reduce? Okay, okay. So by using MapReduce, you can reduce the number of alphabets and its occurrence quicker by splitting across multiple machines and using mapper to separate the alphabet and reduce it to find the count. Okay, and MapReduce will help combining the individual alphabet and give the results. So now think about it. Think about it. You have just A to Z frequencies, right? And to do this problem, all you need is basically this would be my approach without MR. Create a big array of 26 size, integer array, basically 26 counters, which will, using these counters, I'll count how many times A came, B came, C came, and up to Z, 26 numbers. Okay, just to note down how many times any alphabet has occurred. Okay. So I just need a small array of 26 to count these letters. So do the RAM is not an issue. Okay, RAM is not an issue. So Prasanna has given a nice approach, and that will be the probably the right approach to do. But my question is that do you need, when this approach is so simple and your RAM is not bottleneck, what is the bottleneck? Why would you go for MapReduce in this kind of scenario? Depends on the data size. Good. And say you have got 10 GB file, or say 30 GB file. Okay, you've got 30 GB file, and this file is already on your HDFS. Okay, say 30 GB file is there, which is on HDFS. So do you think it makes sense to just do a HDFS concatenate and then run your program, which will just count the number of the frequencies of each letter? Or let me rephrase my question. Say you have got 30 GB file, and moving that file to HDFS is not too much of an issue for me. I can move it if you wish. Okay. So do you think still this approach will make more sense than a MapReduce approach as given by Prasanna? So say 30 GB size is the file, all right, which we are trying to count the alphabets. Because here there is a very important aspect which we should make a note. Here we do not have a we do not have a memory crunch. Okay, in the memory we just require a count, 26 integers. That's all. Okay. Yes, anyone? Hi Jagannath. So finally you've been able to connect. Today Meenal is not there, I think. Great, great. So my question is that, or to all of you, if memory is not a bottleneck, then without MR approach would provide more or less the same performance. Right, right. So it will look like it's the same performance, but if you think about it a little bit more, you will realize that in this CPU is not a big deal. You just have to go from one side to another side on the you just have to scan the whole file from left to right and top to bottom and just count these letters. So what exactly is the bottleneck? The bottleneck is your the rate at which you read the disk. Okay, the rate at which you read the disk. For copying, for reading a 30 GB file will take considerable amount of time. So if you distribute that task, if you distribute the task to multiple machine, you will be able to solve this problem far more quickly. Okay, and so all you need to do is you need to say here the way we had done. All you need to do is let your mapper print characters. Okay, let's say I think I had made a plan. Okay, okay. So although your memory and RAM will not be limitations, the network or disk IO will become a bottleneck, and your CPU might become a bottleneck because it has to do a little bit of comparison and jumping in the RAM. That's all. But most likely, CPU will never be a bottleneck because there is not much of a computation happening. All right. Now, if you look at it, that the way it will happen is that in using map reduce approach, first mapper will give out read the whole line, okay, and then second mapper will read another line, okay, and okay, okay. So say first mapper says that I encountered A these many times, B this many times, C this many times on first machine, and the second machine says this, and there will be 26 such numbers. All right, there will be 26 such numbers, and that will be combined with the another one, and you will get such kind of results. And then reduce will basically sum up these values. All right? So this is the kind of MR approach will solve this problem. Okay. So is everybody clear about? Basically, I have just reiterated what Prasanna has said in this particular slide. Right. So is it clear? Is it clear to you that we do need map reduce even for frequencies of letters? We because the network I/O or the disk read speed will become the bottleneck. Okay. So now the next question in yesterday's discussion was, how do you find anagrams in a Hughes text? Okay. How do you find anagrams in Hughes text? Did anybody attempt it? Here, my question is not how do you whether to use a MapReduce or not. Here, my question is using MapReduce paradigm. What will your mapper do and what will your reducer do to find anagrams? Okay. Yeah. So please feel free to write your approach. I'm waiting. Yeah. So did anybody try to attempt this one? Okay. So function is map for each word in the input, print word array.index. Okay. Okay. For map function is map for each alphabet in the word, print alphabet 1, and function reduce for each word, print alphabet and frequency array. Okay. 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 And function reduce for each. So we're talking about the second one, and here is the okay. So for each word in the input, print this. So and so there are two map function. Which one should I consider, Prasanna? So Karthik's point is that okay. So no, actually one map would be sufficient. As yesterday we were discussing, whatever you can do using single map, you can actually combine the same logic at a one place. Okay. The only thing is that if you want to do using multiple reduce, okay. Now let me see what you're trying to do. For each word in input, print word and array dot index. What does array dot index do? For each alphabet in the word, print alphabet and 1. Okay. For each word, alphabet and frequency array. Okay. Okay. For each index, index span 1, print compare alphabet 1 and alphabet 2. Excellent. Excellent. Okay. 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 This one, no, think I did not get it. Okay. Okay. So it can be solved with the same logic, maintaining a map where key is the frequency count of the letters in the ascending order and pass it on to the reducer. Frequency count as in what frequency count you're talking about, Karthik? Where key is the frequency count? Do you mean to say the key is um, frequency count of what in the letters of frequency count of letters in the input? Okay, okay, now I got the point. So you mean to say, for the, it will be T E1, H1, and T1, right? Yeah. But why do you need frequency count? Can't you just make it ascending order and that's all? Will not that solve the problem? But yes, I like the approach. That's nice actually. Okay, great, great, great. And now let me go through personas. Try to do a multiple mapper within a mapper. Okay. So, okay, try to have index on each word like 1, 2, 3. Okay. 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 So probably persona is also talking about a similar approach. So, I mean, what you are trying to do right now, even if this, right? If you take a word and sort the characters of the array, okay. So, say for example, right? So basically, Karthik, your approach is great, okay. It's just that putting the frequencies is just redundant, okay. Say for cat, ACT is the key, ACT and for ACT is key for all. Cat, tech, act. All we did was two characters and ordered it by ascending. Okay. Similarly, for the key will be key will be EHT. All right, and so on. Right. In case there is a one letter repeated twice. Okay. So let's say, is there any example over here? Okay. So let's say Giri, okay, my surname. Now for Giri, the key will be the key will be your in your case, in my case it will be I G G I R. All right. Okay. In your case it will be G1 and I2 and R1, right? So it's the if you look at it closely, it's the same thing. Okay. And yeah, actually, if any of you could help me understand Prasanna's approach also, it would be great. Okay. So let's say map within map. So for each word in input, print word followed by array.index. So what does array.index do, Prasanna? I'm not very great with Python. Array.length, did you mean to say? Or did you mean to say at what location did we find? Okay, okay, okay. Okay, so it'll be like word 1, word 2, word 3 in the order in which that word exists in the line, in the input line. And then for each alphabet, print A1, B. Oh, okay. So basically it will be in the new line, you mean to say? Yeah? Okay, I got it, I got it, I got it. So both of you basically, Karthik also has done the same thing. You did a frequency array to compute the key. So this logic basically computes the key, right? Awesome, awesome. So actually, this logic you don't require MapReduce because this is being, uh, I mean, your role of the map is basically give out the key, and for key computation, it will be difficult to do this right away. Okay, it will be difficult to do it right away because I mean, you cannot really. I mean, how would I do this actually if I have to do key compute? So basically, in such cases, right? In such cases, you end up using multiple passes of MapReduces. Okay, and moreover, you don't require MapReduce in this case because finding a key in a word, even with your approach, is with your approach, it doesn't require too much of processing. All you need to do is move from left to right, do a frequency computation the way uh, you guys are explaining, and that's it. Okay. The only thing is here, you'll have to make sure that these alphabets are sorted, right, after the reduce. But here you are probably assuming that MapReduce will anyway sort it, so I don't need to do that, right? That is why you have not done that. Great. Great. So yes, your approach is right. Just that this portion, you just have to make it in your code instead of relying on MapReduce. Okay, because you need to give out the keys, a key value to the Hadoop to MapReduce. All right, to MapReduce as in MapReduce of Hadoop. All right. So yes, so this is what it looks like. I'll just go through the approach once again. So my mapper, the role of my mapper basically is to form a key because what I want to do is I want to group together all those all those words which which are formed by the same characters, which are basically the rearrangement of the same letters. Cat, act, tech are the examples. Okay, so that is my objective. I want to find out the anagrams. So all I here we did was took this the, I prepared the key by sorting the alphabets. Okay, that made sure that all the words which have which are anagram of each other will have the same key. No matter what arrangement is it, if you sort them, it will always form the same key, whether it's the or het hat or eht whatever, they will form the same key. So eht is the key for the. For cat, we sorted the characters and the key is act, and similar is this, and then for in is I and all because I is lesser than n, I comes before in alphabets. Tick is similar. Now tech, in case of tech, if you order these alphabets again, you will form act, and hence cat, act, tech, all three have the same key, right? And in the end, you get this sort of a table. This is what your mapper is giving out. Okay, the mapper is giving out this sort of a table: key value, key value, key value. Now after after the MapReduce, when the shuffling phase is, this one has shuffled. I mean the shuffle and then grouping together all the values with respect to a key, you get this kind of table. And each row or each key and these values are passed through your reducer. And what will your reducer do? Okay, and reducer will simply print distinct values for a key. That's it. Reducer doesn't have to do much in this because your your mapper has done the job already. If you see here, or reducer can simply say, null or something, right? In case the value is single, that means distinct, and if the values is greater than one, that means you have found an anagram. Otherwise, you haven't found. So it can return null also. So it will be up to you how do you prepare your output. All right. This will be as simple as this. Does it make sense to you guys? Feel free to ask me. I know that it's little confusing if you are encountering it for the first time. If you want me, I can explain the whole thing again. But make sure that you understand that we have basically exploited the MapReduce paradigm to solve our problem of finding anagram. MapReduce provides you the sorting techniques, where you give out the key value and I mean, Hadoop will sort it for you, sort your data based on the key, and once it has sorted, it will pass you that data via your reducer, and reducer will combine the values for a single key. Okay, so it is, I mean, the most important part is to figure out how do you break your problem into a sorting problem. Okay, how can you exploit this kind of a paradigm? So we always create a dictionary to pass to MapReduce for further processing. No, we don't create a dictionary. We just give out key value, and that's all. We don't create a dictionary. Okay. In case of a Java code, you can think of it as a dictionary. You don't give out dictionary per se, but you give out the way you say dictionary dot put key and value. Similar way you give out that particular single or multiple such operate pairs to as a result of your map code, right? Dictionary means you will have to prepare the dictionary and then give out. No, you can give out multiple such pairs, so key value pairs. It is up to you how many key value pairs you want to give out as a result of your map code. Okay. It looks like you are giving out dictionary, but if I say that it passes dictionary, it means that you anyway had done all of your job. Then what's the point of giving it out, right? So it is up to you whether, yeah, you don't have to give them in sorted order. Good, that is a good way to put it. Yeah. All right. Now let's move on to the next stage. In the key value pairs, keys can be similar. Yes, keys can be similar but not same. In case they are same, the values will group together as a result of MapReduce. In the key value pairs, keys can be similar. Similar in what sense, Ishwar? So let me try to understand. So we have, give me an example. So how similar the key? Before shuffling, mhm, in the key value pairs, keys can be similar. Yeah. So yes. So here cat also, when the mapper gave out, so cat also became, it came out in here, act came out in here, or you can uh, right, right. So here, see, for cat our key was act, for act our key was act, because the way we are preparing key in this particular problem is by ordering the letters, right? And therefore there are the same key twice. Okay. And I mean, your job is to give out these key no matter how many times it comes. The mapper will, I mean, MapReduce will group them together. So it came three times, as you see, not only twice, it came three times, right? In our example, I see two times. That's your question. So here is three times. Now it will group these values together and form this. It means MapReduce. Okay, MapReduce, the Hadoop MapReduce will do this job for you. Okay, so it grouped all the values for a key together, and then reducer gave out actually reducer did nothing in this. All right. So was I able to explain? No. Okay, great. So basically, we wanted the keys to be same for those two, right? And because if we made those keys same for those anagrams, that means we have succeeded. because we wanted to group those words together. Now I'm moving to the next question. Problem number 3A. Okay. There is a file that contains the DNA sequences of the people, right? Okay. And so we have to find out which all people have the same DNA. It's a very simple problem. So see, this is my file. This is my file. User 1 has got a DNA sequence ACGT, while user 2 has got a DNA sequence TGCA, user 3 has got ACG, and so on, right? So the output which we want is that user 1 and user 4, they have the same DNA, right? They have the same DNA. We want them, we want to figure this out, that we want to find out all the people with the same DNA and we want to group them together. That is the problem statement. So what do you do? Yes, yes. So DNA will be the key. After mapping is done, ACGT user 1, TGCA user 2, excellent, excellent. Yeah, great, great. So at the end of it, okay, user 6, ACGT. No, actually user 4 and user 6 will not come like that. Okay, let me just, this guy actually, yeah, if you see ACGT user 1, TGCA user 2, ACG user 3, and user 4 ACGT. And okay, now if I just see that, if I let me just do a sort, this is my editor which supports my Unix commands. Okay, and in case you guys are using Mac, you can also use TextMate or some sort of that editor. Now user 3 and user 5 belong to the same group. User 1, user 4 belongs to the same group, and user 6 and user 2 belongs to the same group. No, they don't belong to the same group. They are different. Now adding to the list. So that means user 1, user 4 is okay, user 2 is okay, and user 3, user 5. User 4 and user 6, no, this is wrong. Okay, you sure? You got it? Only this small part is wrong. Okay? Excellent. So is anybody have any questions related to this? I think this got very, very clear to all. Akhilesh, Ishwar, Jagannath, Karthik, Prasanna, right? Had it been your database table, all you could have done had it been database table, can somebody write tell me a query? Imagine that you have a table containing these column. So what will be your query to do the same thing? So select DNA, comma, concat users from my table group by DNA. Okay. So probably the table could have been like, I mean, the SQL could have, what is wrong with this guy? Yeah. So Akhilesh is okay, Ishwar is okay. So Jagannath and Karthik and Prasanna, Akhilesh. So Is this question is the answer is clear to you? If we had the similar problem in case of a SQL, we would basically do something like this. And similar thing using MapReduce, all we did was we made DNA as the key and user is the value, and that's all we did. Okay? And MapReduce automatically grouped them together. Now the next deviation of this problem is little tricky. Should I move on to the next question? Have I put you to sleep or something? So only I'm getting Akhilesh, Prasanna, Ishwar, and Karthik. And Jagan, are you able to hear me? Okay, great, great. So this is clear to you, Jagan? Should I? Okay, great. Now moving on from here. So see, Akhilesh, the thing is that now the way MapReduce has been structured, they have not been able to you build it like a library. It is more like a framework in which your code runs inside MapReduce instead of you making a call to to MapReduce. Okay, but you can definitely use it. And when we discuss a couple of more libraries, then you will get more clarity on it. Okay, so most likely you would not require to use MapReduce per se. You will be using MapReduce only in special cases. And the only reason why I'm discussing these questions, because this give you a thorough clarity on how does the MapReduce work, because Pig, Hive, and everybody else is actually relying on MapReduce. Okay, even Apache Spark, the new frameworks which are coming in, they use the same paradigm in Apache Spark also. Okay, no, Crunch will not be covering because that's not yet part of the Apache Hadoop umbrella yet, but we'll look into that. Okay, so that's it. Now the next question. Third B. How many of you gave it a thought? So now some scientists said that instead of people belong to the same family if they have either the identical DNA or mirror image of the DNA, completely inverted, which means user 1, 2, and 4 belong to the same family. User 1 and 2 belong to the same family because they are mirror image of each other. Okay? So what should your map do? What is that key the map should form such that people from different families come to from people belonging to the same families come together? Okay, people who belong to the same family have either identical DNA or their DNA is exactly the mirror image. Anyone? Is problem statement clear? So can you correlate? Can you look at this output and then see that whether this works or not? So user 1, user 2, user 4. User 1 is ACGT, user 2 is TCGA, which is exactly mirror image of user 1, ACGT, and user 4 is ACGT again, which is identical to user 1, which means user 1, user 2, and user 4 belong to the same family. Okay, and user 3 and user 5 belong to the same family. User 6 does not belong to with anybody. Okay, so this is just an example set. So what should your map do? Yes, what should be the key? Karthik, Akhilesh, Ishwar, Prasanna, user 1. Okay. Okay, user 1, the value will be 0, SCGT, and the reverse value. Okay. No, I did not get it. So basically, what you have done is there will be two values what you are suggesting. For user 1, ACGT, as well as there will be basically you're forming two key value pairs, and for there will be two key value pairs. So for user 1, there will be basically AG, the for with respect to first one, you are suggesting that it becomes, for user 1, it becomes something like this, right? AG, AC, ACGT, and then user 1, right? And or as well as DGCA, and then you're saying that user 1, right? So you got two columns, to two rows with respect to the same thing, right? And now when you are grouping together, you're grouping together, and yeah, that sounds interesting. Let me see. Okay, now you have got user number 2 and user 2. Same thing will be happening for user 2 also. Okay, now you have got this, right? Now at the end of this exercise, you will get user 2 and user 2. Okay, okay, that's right, right, Ishwar? So I mean, for those basically you will get your values twice, right? You'll get your values twice. You'll have to filter this output again to just take into account only once. Okay, that's interesting. Uh, okay, let me see the other approaches. Okay, Akhilesh, okay, Akhilesh is saying AGCT and its reverse value. Akhilesh, is it the same approach you are also taking, or your approach is different? Akhilesh, maybe you're typing probably. Okay, that's interesting approach, and this is a nice approach. So basically, in your case, Ishwar, okay, okay. For user one, it will be ACTG and ACTG or ACGT. Okay. It will be same, however, I put it as user one equals AC, okay, ACGT, and user one equals TGCA. So still you are also saying that the key will be for each user, for each row, there will be two, two keys you will generate, two key value pairs you will generate, Akhilesh. Okay, okay. So can somebody help me out to figure out that here there's an additional step will be required at the end of the whole cycle to basically eliminate the to eliminate so say this got grouped together. Okay, now we'll have an additional map reduce step where we'll just print out the sorted list of users, like user 1 followed by user 2 and so on, right? Because here it could be user 2 comma user 1, right? So as part of our next step, we'll have to print out ordered list of users. Okay, and then that will get deduplicated by your map, right? So you will require an additional step to deduplicate your users list to figure that out, right? So can anybody suggest an alternative mechanism? Because here in the end of it, you will get users at least twice, even for the single user, like for user 6, right? User 6 also, you will have for user 6, you will have ACGT here, AGCT here, and TCGA and user 6, right? And which means again you will have a similar kind of thing. Okay, we can try reverse key values. Okay, reverse key values as in, mhm, okay. Inverted indexes, it simply means that where did you find the word? Okay, that's called inverted indexes. Okay, basically what should be the key we should form such that these users with the mirror image or same DNA come together. Okay, okay, yeah. So Although this approach, what you guys have suggested is good and probably is equivalent to my approach, and so I'm suggesting one more approach over here. So while forming the key, compare the DNA and its reverse. Whichever is smaller out of two, make that as a key, right? For user one, the reverse of ACGT is TGCA. And which one is smaller out of these two, right? So which one is smaller out of TGCA and AGCT? We have taken that one as your key. We could take also in the same manner, we can also take maximum, not minimum. The idea is that we for these two users, we should get a same key, whether max, min, or uh, you know, but we cannot order the characters. If we order the characters, then this user will also come together with these users, right? The way we had anagram, we cannot do it that way because user 6 will also come. Therefore, compare the reverse of itself. So reverse of this one is this, right? And reverse of this one is this. So compare the reverse of this one and then print the smaller out of two. So people who belong to the same family, people who have either the same DNA or people who have identical mirror image of the DNA, they will have the same key, right? Is it clear? Should we move on? So here minimum of ACGT and TGCA is ACGT and so on, right? Or whatever approach Karthik and Akhilesh has suggested, that's also good, and we can use that one. Okay, and Ishwar, right? The approach Ishwar has selected. Now the next problem is a big challenge. Okay, this is a simple join problem in case of a RDBMS, and this is how the joins are implemented. So the problem, have you gone through this problem yesterday after the class? Who went through this problem? Okay, not me. Okay, Akhilesh did not go through the problem. Okay, I was hoping you guys go through this problem. All right. Now let me explain. So here this a voting is the problem, right? So there are you are given two lists. In this country, not all are equal. Not everybody's vote is counted as equal. You are given a huge list of voters and who did they vote. And there is another thing about these elections. People are voting for each other, which means the voter votee list, the vote total votes are too huge, too very huge. Okay. And so A voted for C, B voted for C, you voted for me, and so on, right? And we are also given the worth of each person in this country, and the vote count is equal to the total worth of the people who has voted for a person. So for person A, who voted for person A? Nobody voted for person A, so the vote count is 0. For person B, who voted for person B is A, and A's worth is 5, and therefore the vote count is 5. For person C, A and B both voted. A's worth is 5, B's worth is 1, and therefore C got 6. Now for F, although F does not have a worth here, okay, but people have voted for F and C voted for F, and so the for F the total vote count is 11. All right. Or you can think of worth in terms of million, right? Or maybe crores in Indian context. So key is person and value is weight count, weight into count. But how would you compute the weight? Remember, both of these list is too huge to fit into the memory. Okay, they have they have billions of record, both of them. So Karthik, when you say value is equals to weight into count, how would you find out the weight of particular person? Because you cannot fit this into memory. Neither list one, not list two. And you have to use join for this. Basically, had you been using MS SQL or any other MySQL or any other RDBMS, this problem was very straightforward. Join these two table on on voter, right? Sorry, join the I mean, for each votee, group the first list by votee, and then whatever comes out, you join it with the second one and find out the values. Okay, first you join it and then group the whole thing with the votee and then find out the worth, right? That's what you will do. In case of RDBMS, how would you do that one? Link join also solve the same problem, right? Okay, okay. But here the problem is the billions of records. Most of these existing platform fail pathetically when we talk about hundreds of billions of record, or this is like 10 billion into 10 billion. Okay, the join will be that one, and most of the systems will fail pathetically. Yes. So key is the voter. So you have got two files. First file containing two values separated by tab A and C, and the second file separated by a tab and this one, right? So first we have to join it such that we can find the worth of each person, right? And then you have to group it. And how do you join two files? Just concatenate them using the way I said input. My input is this folder, so it will pick up all the files inside it and everything will be combined, right? Or you write two separate mapper, one for the first file, one for the second file, and let them combine the result into the same one, same format. Okay. Now, so everybody understood the problem. Is there a doubt about the problem? Just give me yes. Great, 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 great. So everybody has understood the problem. And should we take a quick 10 minutes break and then come back and you also get some time to think about the problem? And remember, this is a very important problem, and probably this is the reason why MapReduce was invented in first place. Okay, this algorithm is equal to the page rank by Google. Okay, and this is the reason why MapReduce was used in first place. In the paper called MapReduce by Google, this is the algorithm that was discussed for which they have invented this whole platform. Okay, so let's just take a break for 10 minutes and come back and at 10:24. Right? Hi guys, I'm back. Are you guys back? Are you guys back? I'm back here. Great, great. So Claes is back, Ishwar is back, and Prasanna is back. Karthik, Jagan, are you guys back? Great. All right. So we were discussing this particular problem. All right. Great, great, great. So we were discussing this particular problem. I mean, the origin of which is basically the reason why most of MapReduce exists today. And here, all we have to do is first find out the worth of the voters and then merge them and then find the total vote count. So this is what I came up with, right? So you have got list one and you have got list two, and mapper will merge these two files. Okay, here. So voter, votee, and both these files are basically being merged, right? So as a result of the mapper, so A, C, A, B, B, C, C, F, this is the first file, and this is the second file, right? And at the end of, so you basically did nothing. Okay, basically did nothing. While merging, these two files got merged. They are by default separated by the tab. So by default, this is your key, and in this case, this is your key. All right, same one. And Hadoop sorted them and grouped them together. So as a result, you get some sort of this, right? A 5BC. So for the key called A, so what we are trying to do is for a voter, we want to list down its worth as well as all the people a particular person voted for. All right. So A voted for B and C, and A's worth is 5. B voted for C, and B's worth is 1. So since there is no problem, mostly with respect to merging these in Hadoop mostly with respect to the values being from different kind. Even if there is a problem, when you are doing a Java one where you have to specify the data type, you just make the worth as the string. All right. When required, we'll convert that into a number. Okay. And hence you will get something of this sort. Okay. And when you sort a string, 5 will generally come before B. Okay. So this step is clear to you. So these two files are merged. In this one, person is the key. In the first list, the voter is the key. All right, and you get a merged list of this sort. Okay, and now Hadoop, as a result of bringing the values of a key together, forms this. Okay, this is clear, right? How we got A has got three values, 5 and B and C. B has got two values, 1 and C. C has got 11 and F, and D has got only 12, right? Now, when we are converting this, now the first phase finished. First phase finished. Let's say the reducer doesn't do anything, or let's say that the next map reduce phase starts. Okay, and let's say take MapRed 2 phase. Let me just It's a second phase of MapReducer. All right. So in the this first set finished, and you got this as the result. In first set, there were a first mapper reducer. The mapper all mapper did was combine these two files, and Hadoop gave you this. Okay, I'm sorry. I'm getting a ping of one of the candidates. All right. Now, up to this is okay, right? Now you got a new file combining these two values from these two files to two files where we have combined this. So now imagine that this is file which is given to you, all right? And now you have to find out their worth. So as a result of this is the only tricky part here. This is the only tricky part. So what I'm doing is I know that A voted for B and C, and A's worth is 5. So when my map, as part of my second map, what I'm going to do is print out the values of B and C by virtue of A voting for them, right? So by virtue of A voting for B, the B's worth is 5, right? And by virtue of C voting for C getting vote from A, C's worth is also 5. So this map is basically printing out these key values B5, C5, A0. Okay, this is an additional step just to get, you know, in case nobody voted for somebody, we should display 0 at the end of it. Okay, just for displaying 0, right? Here, like otherwise, this A0 will not appear in the output. So similarly, so these are the three key values appeared by conversion of this one into by map. So our map job was given this line or given this input, and map did was printed out three key values B5, C5, A5. Basically values of each of these candidates, values of each of these candidates like this, right? Similarly, for C1, the value is 1 because B voted for C and B's value is 1, and so on, right? You see this? Now B equals to 0, we just adding it, this is step so that we can display B equals 0 in case nobody voted for B. And similarly, this step, and similar is this step, right? So this step is okay with you guys, or do you think there is a mistake over here? So basically, we aggregated, first we aggregated on the voter, okay, such that its worth and all the people who voted for it comes in the values, okay. And in the second step, where we are running a completely different set of map reducers now, we have created another map and we are taking input as produced by the previous step. And this map will basically print out three values, B, C, and A, right? CZ1 and B0 and so on. All right. Make sense to you? Okay. Now the reducer step is pretty simple. All reducer has to do is sum up the values. That's all, right? All reducer has to do is sum up these values. That's all. You can think of it now. There is a next step. Maybe there is a next step internally. Okay. So this is not this way. So after it has sorted and prepared, this is what Hadoop does. Okay. Now It will bring out the values of A to the top, right? You can think of it this way, and then B will come up and we get 0 comma B, 0 comma 5. For C it will be 1 and then there will be 0 also, right? As an array, right? Now for D again it will be 0 and for F it will be this. So in the output there will be D also showing 0. Make sense to you? Just that I have not put it in the order, right? Sounds okay to you? And this is how we computed the summations. So in reducer only did was summed up the values, okay, given by the Hadoop. Any questions regarding this? Any questions? Okay. So as an assignment to you guys, okay. So okay, here I have a question actually. Now I forgot to ask you this. Now, do you see any problem with this kind of things? What if A has voted for a billion people? This list will be too huge to be handled by a single reducer. Because reducer, if you remember, it gives you an array and you have to operate upon it. Okay, so which effectively means that in case A voted for a million people, then this list will be too huge. Okay, here we are talking in terms of normal voting. That is why we think that less people will be in this list, right? And therefore it will be easy to, run a reducer or a mapper on this easily. But when it becomes a huge list, it is going to bother you a lot because here also, here also there will be, if a billion people are voting for B, okay, then the reducer has to be run on those things, right? On all those billion numbers. So this array will be too huge. Okay. So there are multiple optimizations possible in these circumstances. One is combiner, other is partitioner. We will be discussing all those very soon. Okay. This array will become a billion people. This array will become a billion people in case of, you know, in case the same problem we discuss about the page rank. How many of you know page rank? Google page rank algorithm, the algorithm that made Google. Okay. So basically, in case of a, okay, great, great. Okay, great. For those who do not know, basically, when a page links another page, say I'm referring to Apache Hadoop's URL. So Apache Hadoop gains the gains the page rank by virtue of my popularity. Say my page is already good enough, and if I give a reference to Apache Hadoop, Apache Hadoop's URL, like href to Apache Hadoop, that means I'm voting for Apache Hadoop. That makes Hadoop important. And therefore all these linking of pages is basically equivalent to one page voting for another. And the rank of one page is the wealth of one one voter. Okay, so if my page is very very popular, my page has got a big set of I mean people referring me, and in case I am referring someone, that someone is going to be far more popular. Someone is going to get a page rank far more higher than mine, right? Basically, all the people who are voting for someone or referring some URL gets the higher votes. So that is the basic idea. Okay. So all the results which come in the search results is the one which comes in the top is generally the one which is having lot of back reference URL. Lot of people referring that one. Okay. Now there is also a couple of scenarios where you cannot use MapReduce so easily. Okay. It MapReduce actually can solve most of the problems. Like you will see, the whole SQL can be converted into MapReduce, uh, MapReduce jobs. Okay, and that's what Hive does. Hive is one such component which does this conversion and translation. Pig also under the hood does this MapReduce translation for you. So, so all of the logic we just discussed can solve almost all the problems with respect to data crunching. Okay, but there are few problems which cannot be solved using MapReduce. First, why and I mean before we say that it's a solution for the whole world problems, I would like to tell you a few limitations when not to use. First, if a job can be done on a single machine in reasonable time, in acceptable time, then there is no point of using MapReduce. Okay? The whole idea is about how fast can we get the results done, or how reliably can we get the results all the time. Second, if your computation depends on previously computed values, then there is no point of using MapReduce. It is very, very difficult to do that. To translate a problem into into MapReduce is actually very difficult. Okay, so for example, you are trying to generate because one key value pair has no communication with the other, right? When you are reducing a value, you are only operating on the values of a key, right? You don't know anything about another keys. So it becomes very difficult to form a logic in terms of MapReduce for lots of kinds of problems. But if you and there are problems where when your computation depends, is the single same computation, same logic depends on other variables, other keys or other things, it becomes very 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 difficult, and sometimes you should avoid using MapReduce in those circumstances, and sometimes you can't use it. Even after thinking again and again, you may not come up with a MapReduce logic. Now, second is when you need it for the on-demand stuff. Most of the MapReduce is done for the batching, where you give your MapReduce logic to Hadoop and then wait for Hadoop to finish. Hadoop will divide, distribute, and give you the results. Because but if you are serving a live system such as ad hoc searching or quick indexing, this is not a great way of solving your problem. There are dedicated solutions for for text indexing such as Solar, SOLR. Okay, SOLR, right? And there are dedicated. Solar is Lucene cousin, and Lucene also is a good one for full text indexing. Or ad hoc searching is where user is looking for some data. That is not a great. If you start preparing the MapReduce for this, the user will wait forever. Okay, but MapReduce is great when your data is really, really huge, when we talk about petabytes or terabytes of data. I have used it for 200 terabyte of data, and it was just seamless. While none of the database can actually handle that sort of data. The other is the if your algorithms depend on a shared global state. If you if inside your map you start making call to any API, trust me, it is going to be a very, very bad, a very, very horrible mistake, because the map is going to be called billions of times, and every time a map is being called and you are hitting a global state or some shared global variable, it is going to hurt pretty bad. Okay. Also, it is not possible to share variables across very maps. Okay, it's very, very difficult to. It's not possible to share variables in the map, because you do not know whether, because the logic you write in the map gets cloned to multiple threads as well as multiple machines. Okay, and you cannot keep something like a static variable available everywhere and all that sort of thing. That's not possible. So whenever you see these kind of patterns, you should avoid using MapReduce paradigm and figure out some other mechanisms or dedicated solutions. Okay. Like for example, we will discuss that other way. For stream processing, which I had been doing at Amazon, was we had to build a solution from bottom up. Okay, for doing that, because that required a data processing at a fast pace instead of very huge data. Instead of very huge data, it was data at very fast pace. So that sort of problem is called a stream processing problem. So in those kind of problems, you do not should not be using MapReduce. Okay. The other things, in case you are interested, so a bit of about, right? So when you how to test your MapReduce jobs, first you should be testing your MapReduce job on a very small data. Then separately test your mapper and reducer independently. And in case you are using a streaming job, then testing is really, really smooth. Okay, you can say whatever your mapper is there being passed to a streaming job, you can execute that one in this way. This is your input file, cat input file. Give it to the mapper. Whatever output comes from the mapper, run a sort command, and then pass it to MapReducer and save it to output file. And that's all. It's so simple, right? Okay. And the only thing is that this will be executed on the single machine, and memory or all those, it will not be possible to run it on multiple machines. So this will give you a quick test. Most of the streaming jobs I have written in past, I have used this mechanism, and this is just beautifully runs. It beautifully gives me output very quickly. So even if I have like 10 mappers and reducer jobs, I prepare a shell script having these kind of command, which will quickly run my mapper and reducer and test my logic. Okay. So this is a way to execute your mapper and reducer without using Hadoop. And this can run on the machine where there is no Hadoop. Okay. Similar is your, uh, you know, in case you are coding in Java, you're writing your code in Java, then MR unit does a good job. Okay. MR unit does a good job, but you need to write the plumbing. Okay, you need to write the plumbing of comparing results and all that kind of things. We'll talk about we'll talk about this one very soon. Okay, all right. So this is what it is. For those who are inclined to the Java, this is how it looks like. So you have got, when you are from Java background, this is how this is what you will be doing. First, you will create a class called mapper, which will extend a mapper interface where you will define a template that this is going to be my input, out input key, input value, and then output key, output value. You're declaring that this is the data type of my input and output. Okay, and similarly, then you will write your code in a function called void map, and that's it. So this is sort of a contract, or the way we do always with respect to any programming language. We are saying that we are implementing or extending a particular class, and here is my logic. This is where you will write logic, where there is to do implement is written. This is where you write your logic. And once you are done that, then you write something called reducer. You create a fresh class called reducer, extend abstract class called reducer, and reducer, you define that what is my data types. Okay, and accordingly, in this function you will have to implement called void reduce. This function has got two values, in three values. One is key and the values, as we have been discussing that Hadoop will do aggregations of the key values. You will basically you'll do that. Here you will use the context. You'll write your key values into context. Okay, I'll give you a demonstration of this one. And yeah, okay, so let me just show you that there might be a little bit of in case you can't see the font in my Eclipse. So those who are from Java background, okay, because we have some around half an hour left, so I'll just cover up a little bit more about of the next class, because you have, and in case you have more questions, so we can discuss questions rather than jumping into Java right away or jumping into the next session. Okay, so you don't have any questions to me? So I'll move forward and go ahead with the demonstration of Java code. I'll walk you through the Java code. So I think only one person out of the batch is okay with Java, right? I think C Sharp, okay, Akhilesh will be okay with this one, okay, because it is in C Sharp. Okay, this. So anything is okay, but I prefer Eclipse because IntelliJ is I mean, IntelliJ cost you. Second is that there are lots of plugins available for Eclipse right away. I was earlier I was earlier using IntelliJ IDE for writing code, but now I'm far more comfortable with Eclipse. Okay, so probably Eclipse will do a good job. Okay, so now let me just I mean, All of you, in case you have questions related to MapReduce, you can ask now. Okay, since I have got some half an hour, I'm going through my Java code. In case you have questions, you can ask. Okay, great. Because we have got enough time. S- So, okay. So for here it is. So this is how. So this is again the same example where we were counting the lines, counting the words. Okay. So this is my mapper. Mapper. Basically, this is like most of it is from your code is only this part, only this part. Okay, here this is a standard way of writing any function. You extended a mapper, you defined the data type for the key and the value for input, and key and the value as the output. By default, mapper gives you the mapper when you are reading plain text file, it reads a plain text file and gives you this form. You get the key and the line in the text in case it's a text. And once you got the line, you we are splitting that line by space or tab. Okay, and for each of the split, for each of the words, we are iterating through the array, and then we are printing the context as the word itself and a one. Okay, so when we talk about Hadoop, though they created new classes to represent number. Instead of using the primitive type as one, they're using long writable because otherwise there are high chances of memory overflow. Okay, so since when we deal with big data, the data may not fill into the existing data types. And there is a serialization issues. So they ended up creating their own classes for this. Okay, and people from the C sharp background should be able to understand this pretty easily, right? So we splitted the line by space, any white space, and then iterated over words. For each word, we printed the word itself as the key, and the value is numeral one. All right. So that is our mapper, and this is our reducer. So our reducer is basically of this form. Okay. Reducer, text, long writable, and that one. Now, here the important part is this is where you write the code. Basically, you are implementing a function called reduce, which has got it gives you two things. One is key and the values. Okay, here all we did was we iterated over the values. Values is sort of iterable. Okay, so we said we'll go through each values and add the value to the sum plus equals to that value. So we iterated over the values, added all of those, and that's pretty much. Okay, and then in context we wrote key and the sum. Okay, so as a result we got this. Right, now we have written our mapper, we have written our reducer. Now the next step is to wire this up. Okay, to wire this up the way we when we launched Python job, we provided various command line arguments like which one is my mapper, which one is mapper, which one is my uh, reducer, and which one is my input file and which one is the output file. In the similar fashion, we use the driver to stitch it up. So for this is my driver code. This will be my entry point. Okay, this will be my entry point, and here is the way I have stitched it together. I said create a job on my job config, and this is my entry point. Okay, set jar by class, and then I'm sorry. Here. Okay. And then I've said this is my mapper class. Stub mapper is my mapper class. Stub reducer is my reducer class. And that's all. There's a combiner. Right now I've used this one, but it's not required. Okay. You don't have to type all of this. Just for example sake, I have written it. And number of reducer tasks also you can specify. By default, reducer is generally, you know, in case of a Java map reduce, the reducer is decided by the framework by itself, while in case of a Python, the reducer is generally one. Okay, so it is up to you how many you generally the logic behind deciding number of reducer is how many free machines have you got. Okay, how many free machines have you got? All right. Now add input path, set output path, and all of those, and then you wait for the results to finish. And why we have done system exit? Because this is Java program, it will not end until because Java machine is running for this one. So once you are done, you prepare your okay. Where is my file? File export and then jar file, and there I say this is my this one, this is my jar file, and I say finish and I say override. Now the training.jar contains all of my logic. Jar is as we discussed earlier. Okay, so now this training.jar we are taking directly to the HDFS. All right, and how can we take directly to the HDFS? We go to the web, go to the browser, not this one, we go to the triple A, this port. What happened? What is wrong with this? Who stopped it? Am I doing something wrong? Anyway, if that hue is not available for right now, I will check just after this class what exactly wrong. So anyway, that gives us an opportunity to explore how do you transfer a file from local system to our server. So first thing is there is a command called scp. Okay, in case you used it earlier, will be good. So using that one, I can specify. Okay, so I'm copying this file over to my network. Okay, so it will copy it into the home folder of the student, and this is my home folder, and then I can move it to my own folder. Always move it to your own folder. And if you go here, you can see the training 2, which is of the today's time. And then I say Hadoop file system, and then copy training 2 to to my home folder in the HDFS. Okay, I'm copying right now. First I did what did I do was from my local laptop I copied it to Hadoop one. Okay, now I'm copying from Hadoop one to the HDFS. Not CP. We'll have to use not CP. We'll have to use copy from local. All right. Now we have got in asgiri that command. Now let's see if we can run Hadoop jar and I say asgiri and also there is okay there is so Hadoop help jar. Okay, command manual, this is the one. So if you have a jar status, can submit using that one. You can see the okay, and you have got main class. Okay. Now I'm looking for a particular variable which basically lets you copy the file onto the network. Okay. Okay, never mind. So we'll see that later. Now we have copied it here. I say Hadoop jar, Hadoop jar training 2, and then my input directory is asgiri word count slash input, and my output directory is asgiri word count, then output j. I'm putting it j, right? Otherwise it'll give an error. Oh, sorry. And before that we have to give our entry point. Now where is my Eclipse? This is my Eclipse, so I'll just say driver. Okay. So let's see what error do we get, and we'll debug that error. Okay. Hmm. That is the one, right? So the file archive can be distributed by setting the property map.cache.file archive Okay, and it says that, yeah, okay. So what does it say that did it create any file at all as kiri.output word count? So nothing has been created in output J. What does it say? Class not found. Stub mapper is not found in this one. Stub mapper is again not found. Okay. So why stub mapper is not found? Okay. So maybe I'll have to change my Java build path for this one. It's already 6. So I think it should work. Okay. I'll have to see into the detail. So in case you get these kind of errors, you should generally see the timeline service, or you can see the URL that tracks the service status. So this is where you can see what exactly has failed. This time all has failed, nothing has been successful. And it says that that particular class as stub mapper is not found. Okay. Is there any other log available? Okay. Okay. So on all the nodes, Hadoop 3, Hadoop 4, Hadoop 2, we got the same error, right? We got the same error. So if you see that we basically had a, we are running it on, okay, we are running it on Hadoop 1 and we are getting interesting logs from all across. So we are launching it from Hadoop 1. If you see, this is the Hadoop 1 and we're getting logs from all across. So the problem here is that it's not able to find that one. Okay. Now we can also try couple of, okay. So here, where is my mapret.cache file? This one we can try. -d, the way we pass arguments to. Alright. Okay, I'm just trying to execute it. Looks like a lot of commands have changed. Okay, so that directory already exists. In those cases, it throws the error quickly. So in most of the cases, it is actually possible to do a -d. Okay, again it has failed. So probably we'll just try to do something else and figure out what exactly is wrong. Because this is the example which have been running very well and there had been no problem so far in executing this one. Let me see if I can copy it to Hadoop file system. Now copy from local and then I say ascii. Okay, and it's already there and ls ascii. Okay, now users student ascii. This is strange. What? Okay, that scared me. I thought where have all folders gone? Okay, okay, okay. Never mind. I'll get it fixed and then we discuss it in the next session anyway. Okay. So basic challenge right now I'm facing is that my MapReduce is failing on all the four nodes in Hadoop 2, Hadoop 4, and let me see if I can get it fixed before the next Saturday. All right. And so anyway, that was anyway due for the next session. Okay. Now, so the assignment for the next session, before next class, is that whatever four problems which we have discussed today with respect to MapReduce, please write it in your favorite language, whatever is your programming language, whether it's C Sharp, Java, Python, or Perl, or whatever is your favorite programming language. Use that one to code all the four examples which we have discussed today. All right. And you have got like six days from today, and basically it's not that big a problem. In case you are not very comfortable with any programming language, feel free to write pseudocode. That's also completely accepted. All the four problems, all the five problems actually, one, two, three, 3A, 3B, and 4. All right. And there is this another problem which I want to give it to you. Okay. Just think over it and try to solve it. All right. So nowadays you must have been using the mobile. As you type a word, it gives the recommendation of the next word to be typed, right? So the way it happens is that using the standard dictionary, a lot of text from the internet, people have gone through the word suggestions based on the word you have just typed. It has kept next word, next four most frequent word to be displayed to the user. Okay. So if you're given a very huge text to yourself, how will you prepare the next word recommendation? So you are given a huge text containing what do people generally type or what do people generally write, right? All the words. Now you have to prepare something like this. If you have got a huge text, say people type happy, and you have figured out from the data that after happy, it is generally birthday or new year or marriage that comes. Okay. So you have to give these recommendation. How will you build using MapReduce such kind of recommendations? So you have to keep these kind of recommendations ready for the general words which people type. Okay. So is the question clear to you guys? Akhilesh, Ishwar, Jagan, Karthik, Prasanna, is this question clear? So you have to prepare these recommendations. The whole Wikipedia is available for downloading from this place. You can download the whole text, dump it onto our servers, the whole Wikipedia text, and try to generate this. Yeah, similar to autocomplete. So when you are typing using standard Android keyboard, as soon as you finish typing a word, it starts giving you next five recommendations. Based on what you have just typed, what do people generally type? Okay. It is similar to autocomplete. All right. So try to complete those four problems as well as attempt this fifth problem, and then we will discuss the various kind of difficulties using the existing mechanisms which we have learnt yet, the limitations of the things we have learnt yet, and how can we solve it. Okay. So we'll discuss in detail in the next one, specifically the next session, the session which is going to be on next Saturday. It is going to be, I mean, half of the session is going to be about Java only. Okay, about Java only, and the rest of the session will be maybe general. And next Sunday, we'll stop MapReduce, and next Sunday we'll discuss about the you know pig Latin. Okay, we'll discuss the pig Latin from Sunday onwards. All right, or maybe the pig Latin might start on the Saturday itself. All right, and in the meantime, I check my servers. My Hue it has stopped working, and a couple of more things have stopped working, and I'll get it fixed. But you finish your writing programs, and the streaming job is anyway working fine. We had just tested it. All right, so there's no problem with respect to that one. Okay, so thank you very much for your patience and yeah, and giving attention and asking wonderful questions. So we'll meet next Saturday again. And then in the meantime, stay connected, keep sending email. And I may not write a huge email in response. I might reply you very quickly. So whatever your questions you have, you write to Hadoop at nobigdata.com. Hadoop at nobigdata.com. Okay. Most likely I'll be answering, or one of the TAs will be answering your questions. So feel free to ask. Yeah. Thank you very much. And I mean, in mid week or anytime, you should be asking various kinds of things. Okay, I'm hoping that you'll ask. Okay. Yeah. So great. Good night, guys. And for some, it might be little morning. Can we create a group email so that everyone gets to share? Yes, yes, yes. Okay, I forgot to tell you that on Google Plus and I have created a email. Okay. Okay. Anyway, what I will do is right now creating mailing list is not so easy. Instead, I'll just put my yeah, you know, I email to all of you so that you can reply to all and keep the discussion going. Okay. And here there is a a group which we have created, a community. I'll add all of you to that one, and then you can carry on the discussion. Okay. And in this class, in this Hadoop online group, we have all the students from all across the sessions. Okay, they keep sharing things. Okay, so you should join this definitely. Okay, I'll invite you to this group and then you can join this. Okay. Okay, then I'll add all of you to this group, and this group contains all the people from all our batches. You can have discussions with them. Okay. Thank you very much, and let's see. Let's finish these problems by next Saturday, and so that we can have further discussions also. Okay. Bye bye. Have a great day. Have a great week ahead. Bye bye, Prasanna. Bye, Ishwar. Bye, Jagan.